Get this all rolling.
Okay.
I don't know, maybe I scrolled too fast and hit unlisted. Oh, yep. Yeah, I must have just scrolled too fast. Oh, yep. Yep, so as soon as you get in, just mute the mic there. And then you'll just listen to me. Alright. So, cool. So, I don't know how much you can see. I just did a screen transition. Can you see yourself?
Where would I be? On Google or on YouTube?
YouTube.
Okay. I just refreshed again because I didn't see it pop up.
Oh, okay.
Okay. Live now.
Yep. Can you see yourself?
I'm still waiting for it to load. Yes, there I am.
Cool. Like, look at the screen delay, I guess, a little bit.
Yes, there I am.
See, you gotta silence your YouTube now, because otherwise it's gonna play through a million times over.
How do I do that?
You just mute the YouTube. Like, you just click the volume button on it.
How do I do that?
You just mute the YouTube. Like, you just click the volume button on it.
Oh, okay. Got it. Got it.
Neat. So hopefully that just doesn't replay over and over and over and over and over.
It probably will.
That'd be funny. So hopefully that doesn't.
It is a little delayed. It probably will.
Got it working though. Hi. Good morning, folks. We got some people in.
Am I able to see who's here?
By the comments. You've got the comments on the YouTube link?
No, they're not up. How do I do that?
That's a good question. Are you in like super full screen?
Yes, but I'm gonna
Yeah, you
minimize
need
it.
to. Yeah, you need to be in like the theater mode or one of those. Oh, hey Brady, how's it going?
Oh, now I can see it, I think.
Oh yeah, Paper Mario, nice, nice profile pic.
Yes, I see it.
Cool. All right, well, we'll just wait a minute. I'm doing pretty well. Yeah.
I'm doing good. Trying to figure this stuff out.
Yeah, we're trying to get this all digitized and working. As you can see, it's a work in progress. We'll just wait one more minute or so and then we'll get started. People will probably join in as we get going. If you guys want to reach out to anybody you know in class and let them know. I did post it on the Google Classroom though. You guys must have seen it.
It looks like some people did. I'm replying to somebody now that asked if we were on.
Oh, cool. Yeah, we were a little bit delayed. Well, hey, two's better than zero, right?
Yes, absolutely.
Oh, cool. Yeah, people should probably enable notifications given how we're doing these things. That's smart on your part. Yeah. Also, going forward, we're going to have a bit more of a consistent schedule. So, if you guys are, we did like one at 9, one at 11, these 2 different days. We're going to be strictly doing this at 11 on Mondays and on Wednesdays. So, those are going to be like our days for regular, lesson PowerPoint type stuff. So, it will become a little bit more consistent as we go forward. We'll have a calendar with that coming up soon. We'll probably make that and post that out sometime this weekend.
The delay is funny.
Yeah. I mean, I have it on a 0 delay, but that's the best it can do.
Yeah, no, it's okay. Are you guys hearing me in real time and just seeing me delayed, or is it both?
Yeah, it's
Okay.
different for you because I'm broadcasting our meet and then it's going through the stream and then going to YouTube. So for you, you look delayed, but for everybody else, you're spot on.
Okay.
Yeah, it's kind of funky how I had to do it,
It
but
is weird. Okay.
yeah. The things you have to do to make yourself look like you're on the news trying to get people on.
Yeah, it's funny.
Hey, we got 3. Yeah.
Yay.
Wow. I guess Friday's a no-go day, huh?
Yeah, I think so.
Well, once we get more consistent, I guess we'll have more people show up.
Absolutely.
Anyway, we might as well get started. People can always watch us later. Hopefully, if that's what you're doing, you've found our new schedule, which will be posted on the classroom sometime this weekend. Today is April 3rd. It's Friday. So,
Happy Friday.
Yeah, happy Friday. Anyway, folks, so we're going to get along with what we were doing today, which was we were just simply finishing up where we had left off. We had talked about water. We had talked about the different types of weathering, physical and chemical, and we had just gotten into looking at streams and how they erode and how they deposit and why they are so gosh darn squiggly. So the first thing we wanted to start off with was the same question we went over, and yes, this is overview, but where does water move the fastest in a stream? That was our first question, and we came to this GIF, right? How delayed is it for you, Mrs. Ostromovich? Did it click
A
through
little
yet?
bit delayed. A little
Alright.
bit delayed. Yeah.
Fair enough. Well, anyway, so we've got this GIF, right? And you can see that the water is certainly moving faster at some parts than in others. I'll use the mouse here. You can see the inside here where it starts to have this line jutting into the stream, right? It's curving around this. You can see some of the sediments that are at the bottom. You can see it's not really moving so fast because you don't see all those little glimmers of light at the surface. But what you do see is all those glimmers of light going to the outer edge. So you can see here, right, if you follow that curved path on the outside, that there's a ton of water looking like it's flowing because, well, it is. It's moving faster to the outside. We had mentioned that if water is like you in a car, when you take a really, really sharp right turn, it's going to throw you to the opposite side, right? If you're in a roller coaster, right, and you get thrown to the left, your whole body goes, whoa, to the right. So, same thing happens to water as it's going through these channels. It's going to whip from one side to the other depending on how it's curving. And so that brings us to the next part. So we watched this YouTube clip in class, and actually we'll probably want to post this PowerPoint so that you guys can click through and watch the videos and go over it. That's definitely something I'm going to write down right now, post the PowerPoints. But Mrs. Astromovich, what's the big takeaway from this picture?
Okay, so when you are on the outside of the curve, you are moving. I'm a little bit delayed. We're on erosion deposition, right?
Yep.
That one just popped up?
Yeah, the
not
one with
the
the link
stream
at the
one.
bottom.
Okay.
Yep.
Okay. All right, so erosion deposition. Sorry, guys. I'm in a little bit of a delay here. So on the top of the curve, where you see that peak, it says erosion. That is the outside of the curve. The outside of the curve is where you are going to have your sediments taken away, and they are moving to the inside of the curve where they will be deposited, right? And you notice that everywhere you go to the outside curves, you have erosion, and on the inside you have deposition. So that's where it's going to be building up, and the way that your streams are going to look is going to be changing over time.
Yeah, that's another really good point. With a stream and these two different things, one clawing away and one building up, it's going to change what it looks like as time progresses. So we'll get to that. We have an animation for that, looking at the evolution. But before we get into that, just looking again at the speed, you've got the velocity in a straight stream moving the fastest in the middle. Excuse me. So if the stream was perfectly straight with not a single pebble or anything in the way, just like a total straight shot, the fastest water would be in the middle. So why? You might be asking yourself, well, there is less friction in the middle. It's free to flow. It doesn't have to go on the edges of the bank and scrape along all those rocks and sediments that are there. But as soon as we get to the view where it does start to make these curves, you're going to get your fastest water throwing to the outside at all times. So that brings us to this picture, which has the curve and the two arrows. So at A, that would be the inside, and you can kind of see the way we were talking about in class as well. If you look at the shape of the curve itself, you can always know it's the inside because it looks like the stream is squeezing around that point. See how it looks like the stream is wrapping around the A and it's leaving B totally like on the side. So A would be the inside. You could see that's where the slowest water is. And then B being the outside, that is where the fastest water is. So that brings us to those two different cross sections we were also drawing in class, where if you have the straight cross section, it will make more of a V shape, where it's centered in the middle, where that fastest water is going, and it's deepest in the middle. But that isn't necessarily true for if it is going along the curve. So if it's completely straight, it makes more of like that V shape where the lowest is in the middle. But then if we are looking at the other one, the curved, you can see that the water is moving fastest on the outside, and so it makes this funky shape here where the fastest is no longer in the middle, but it is pushed to the outer side. Also, no, we were covering this in class. This shouldn't necessarily be new. I know it's been a long time since we talked about this, but no, we're just finishing up streams and the total recap on streams.
Right. We did this maybe like a day or two before we last saw you, I think.
Yeah. And the last 2 days are certainly a blur because things were starting to get a little, crazy. But we did touch on this. You should have, this might jog your memory. You should have this worksheet somewhere if you still have your earth science stuff. Oh, hey, Max. So with this, we had a worksheet that looked like this. This is just the color version. And we had A to B, C to D, E to F, G to H, and I to J. So with this, again, you had to simply list, like A and B, which one is the in and which one is the out. So guys, in the chat, why don't you do that? For A and B, why don't we talk about which one is the in and which one is the out? Is A the in or the out, or what's B?
And if you really are unsure, let us know. But this is definitely something we did in class before we were not together anymore.
Yep. All right, so A is in, B is out, and gotcha. It's all right. Yeah, it's all right if you're a little fuzzy on this. Again, it's been what, 3 weeks? So, whew. But anyway, yeah, A is in, and again, you can tell because if you follow my mouse, you can see that the curve is going around the A, and it's leaving B on like the outside of that. Right? So the inside is where it's going around. Like if you were to draw a circle, right, it would be kind of following that shape around the A. That's one way that you can tell.
Another way that you might want to think about it too is on the outside curves are, for the purpose of this picture, are larger. It would take you almost a longer time to get through it. Like if you think about it that way and just looking at it visually.
Yeah, that's a good point. All right, so A is definitely the in, B is the out. So what does that make C and D? Okay, we've got C is out, D is in. Good. Absolutely. So, absolutely, that is what the answer is going to be. C is out, D is in. Again, if you follow those little tricks, that'll help you. But the whole reason that we're doing this is also so that we can get into those profiles. Now, it's a little hard for us to practice that here right now, but just so that you can get a sense of what they look like, right? Let's go back to A and B. So if we look at A and B, and I have it completed here for you, if you go to A and B, we said that A was the inside and B was the outside. And again, since water is moving fastest on the outside of the curve, that means that the lowest part should be pushed towards that outside part. So if you look from A to B, you can see that it dips kind of gradually, and the lowest part is towards B. That's different than if it was straight. E to F is a straight section, and you can see the lowest part is in the middle. So that's what they want you to know for this whole thing with streams and the channels, is that if the water is on a curve, it'll push all that water to the outside and it'll dig out the outside of it. So it'll make the shape move over like to that outer side of like the channel.
Another thing that you're going to see when you look at pictures like this with the profiles is you might be asked questions like, where is the water moving the fastest? And Mr. Duprez said this before. The water is moving the fastest on the outside and slower on the inside. And that is what you can also identify in those profile pictures.
Yeah. Cool. All right, so just another picture to show a little bit of a difference. This has like coloring for where things are being deposited, and the black is showing where the fast water is going to, and it's clawing it out. So you can see that the buildup makes it super curvy. Right? It says here, where there is less water on the inside, there is more friction and slower flowing water. And then for erosion, fast flowing water with lots of energy is directed to the outer bank. So that is the progression here, that the fastest water is going to keep flowing to that outer part, and it's going to keep bringing up, right, keep eroding that bank so that it gets, further and further and further out, while the inside is building up and it's coming further and further and further in. And so we get to this, right, the evolution, how it looks over time. So this was from 1984 to 2012, and you can see the stream does not stay the same at all.
Hopefully you remember this picture from our last couple of days together.
So you can see that all of the different loops look like they get loopier and loopier, for lack of better words, but they continue to loop and push out and get more extreme, right? They don't ever really, as they are a small loop, go back to being straight. It can happen, but it's going to tend to get loopier and loopier and loopier until it does snap straight from being too loopy. Right? It's meandering too much. So if you look up here in the top left part, you can see that it gets really, really, really curved, and eventually it does make a straight channel again. And that is the progression of streams, that they meander, they get curvy, and then they get so curvy that they eventually snap back to going straight, and it continues over and over and over in that way.
But also keep in mind that that's a long time period. It's not like a couple of years or, something like that. It's over quite a long amount of time for that to happen.
But that's in Brazil or the Congo. Well, it's wherever the Reserva Comunal El Sira is. I don't know exactly where that is, but you can Google it and let us know. So anyway, folks, pretty much it. That's all we have for you today. That's where we had ended up last time. Guys, do you have any questions before we go? Yeah, no, we wanted to do a mini lesson today just to see how the video would work between the two of us, cover the rest of the unit. New material is going to start next week. Are we doing Google Hangouts or anything like that? We're going to post a schedule this weekend, and we'll get into how we're going to be doing all these things. We do have a little bit of scheduling since we're really getting everything going. We have a few different classes, so we don't have it right now, but we're definitely going to have like a nice calendar for you so that you guys know what's going down next week. Yeah,
definitely. Check the Google Calendar. Reach out to either one of us, and we can answer your specific questions if you have any today regarding, how things are moving forward. But we'll have a more consistent schedule up for you by Monday.
Yep, but we're definitely going to have some form of like actual communication where we can talk and figure things out together. So, yeah, absolutely. Anything else, folks? Happy to stick around for a minute if you have any other questions. Oh, what about the lake? Sorry, did I miss something? Let's see here. How is the lake formed again? Are you talking about the Oxbow Lake?
Water. What do you mean by that? Be a little more specific.
The Oxbow. Yeah, okay. So you want to take this one?
Sure. If you look at the diagram that Mr. Duprez still has up, if you look kind of like in the middle of the page, you'll see that horseshoe looking shape
Talking about
that's
this
forming.
one?
Yeah, maybe Mr. Duprez could hover over it.
Yeah.
You see what happens over time is that it meanders so much or gets so curvy in a sense that it meets itself on both sides. And when it meets itself on both sides, it separates from the stream that's flowing, and you have that separation where it becomes what's called the oxbow lake. Let
And
me know if
that'll-
that's out or not.
Yeah. That'll stay as a lake for only so long because it's not really getting new water. It could stay for a little bit, but usually
It
those
will
things dry
eventually.
up. Yeah.
Yeah, it does eventually dry up over time.
Is that good, Mr. Perla? We will get a little bit more into that next time we meet as well.
Guys have any other questions for us?
Cool. Well,
All right.
folks, yeah, have a great weekend. Have a great day. Still early,
Yeah, enjoy.
and like
We'll
we
see you
said,
on Monday.
yep, we'll see you on Monday, and we'll have that schedule posted for you. Let's just say Sunday to be safe. It might be earlier than that, but we need to work out a couple kinks of timing. So, with that, see you soon.
Bye, guys.